even in Java you can't, but it's bad. Like,
Right.
You pretty much have to carry in the class type. So you can have a generic type, but then you can also carry around the class type of that thing, and that might not always match. I mean, it doesn't have to, right?
Right.
Like you could feed it a bad value.
You could.
Yeah.
It'd be fun. So like one of the ways that Scala does that is through the manifest class, which is now deprecated in favor of like type tag and class tag, which I still don't use but should. Yeah, you can get access to that class type, but it's a hack.
Yeah.
So, here's another function that does the first element in a generic tuple. Its actual type signature on the command line then here is a tuple of nothing and any to nothing, which is fun. Let's see what happens if we do this. That's interesting. Okay, I didn't expect that, but maybe I should have.
So what is the nothing in reference to? Is it?
It really is the bottom type. It's
Okay,
the
that's
name of the bottom type.
That's the name of the bottom. Okay.
Yeah. All right, so that was an interesting diversion. I guess we can look at.
So another benefit of the nothing is when I'm writing, like for example, a really complex function, especially a for, when I'm writing a for comprehension, there is the triple question mark has been defined as that type, and it automatically
Placeholder.
Yes, so that way I can write out a bunch of code and then throw, the function's constantly, the IDE's constantly telling me the function's returning wrong and doing all sorts of maniacal red lines everywhere. So I just dropped to the bottom right before we close brace, do triple question mark, and then go back up and continue editing so the IDE isn't driving me nuts.
So that brings me to a question that I had recently, because I was doing a little test for this company, like, hey, can you do the Scala thing? I was like, okay, I haven't done this. I was looking at some example code online, and the functional programming book has triple question marks in there. So I was looking at that. I was like, okay, so I know I need to do these things. Like in Haskell, I can literally put an underscore, and the compiler's like, hey, this type belongs here. I was wondering, can you do that in Scala code? Can you say, hey, compiler, what belongs here?
No, because underscore gets used for other things.
Is there something equivalent? Like the triple question, can you use that to say,
Well, so
hey,
what
tell me
triple question
type
actually is throw new exception.
That's right.
And the reason it can do that is what is the type of that expression? I mean, if I were to write out this is now an expression in Scala. It's not a statement because throw is a keyword, but everything is an expression. What is the type of that expression? If I were to say error
Unit?
Throw.
can I get
Do you want, are you looking for the type?
Isn't it f type?
Or isn't it just colon type?
Oh, because you're in the REPL?
okay?
He's an
Well, I'm
Ammonite.
actually an Ammonite,
Okay.
and I was trying to get
Go
it.
back to the rep.
Yeah, let's go back to the room. Okay, fine.
Oh, it's type nothing. Okay.
So it's the bottom type. So that feature probably.
Oh, that's all
doesn't exist.
the triple question mark. And that way, if the code executes, it throws the,
Right.
hey, you just ran into something you should.
And because we're in a
implement here.
language with subtyping, nothing is a valid subtype
Right.
of
Okay.
anything that's out there.
Okay, so my question is no. My answer is no.
Well, your answer is we can do it by throwing an exception because now our code is unsound, and the only way to get a nothing, which cannot be inhabited, it's a type that cannot have any inhabitants, is to throw an exception, is to halt computation.
So then I have to execute it in order
Yeah.
to get that. Okay, that's, yeah.
Well, you do a compilation in an IDE and it goes, hey, I just did a triple question mark.
Yep. So it's a way of knowing that either your computation, so in standard Scala land, a function of type nothing either never returns or it returns with an exception. But either way, it's never going to return normally. There's no way for it to return normally and return nothing.
Same thing as undefined in Haskell.
Right.
Okay.
Okay. So, oh right, we're going to look at the interpreters. So I think this is the one that really makes the Haskell and F# and OCaml guys, it makes their eyes bleed, because this is how we do algebraic data types in Scala. Now, it makes Java guys jump with joy and glee, and they drop down and praise the world, because I can now have, n of these things across the top, and I get a case class and it has all of the magic that I want. I get a nice toString, and I get a hash code, and I get copy. Oh my God, it's brilliant. But we look at this from the Haskell world, and it's like, why the hell is there all of this noise on the line? So let's look at actually what's going on. We're putting together here a simple interpreter example. At the top, we have a sealed trait. So what sealed means is that this is an interface or a subtype that is going to be instantiated a finite number of times, and it can only ever be subclassed from within the same file. So that means that we have a known arity when we're done compiling, so that we can do exhaustiveness check. So things will be safe. Trait is basically like interface from Java. It can do other magic stuff, but, well, that's OO, and we don't care about that. Case class here, we have class as a way of doing just like sort of a standard generic object. What case is going to do is say that, hey, we're not doing just regular OO here. We actually want to declare this as an immutable type. So the Scala compiler is going to inject, when it instantiates your case class, all of the additional magic that every Java programmer has always wanted. Because every time you throw together a data class in the Java realm, you really want to be able to print out your class. Well, here you just get it for free. You want a hash code that makes sense. Well, here you just get it for free. So you've got toString, you've got hash code. I want to be able to copy my immutable data and get things out of it and instantiate new ones. So here you just get that for free. So you get a copy method with sanely set default parameters, where you can actually, in a very, you can override individually which elements in an instance you would like to. So you don't have to like copy everything down from your other instance. You just, I just want to override this one field with this. And it's very nice and pretty, works really well.
Equals? Yeah.
Oh yeah, you get equals. You get
unapply for pattern.
And you get unapply, which is really nice. You get all of these brilliant things just by saying case. 4 little letters. And all of a sudden, your Java experience, you wonder why you ever did all of that.
And compiler generated means now you're not writing the code. I don't know how many times I wrote the code in Java to do these same things, and you forget a freaking, all it takes is forget one thing, like the hash code's implemented incorrectly, just once.
Yep.
And it's miserable finding that thing down.
Or you add a field and you don't remember to add it to string and hash code. So yeah, you never have to worry about that here.
Yeah.
So the line noise is basically, well, we're trying to keep it the same as object syntax. So we're going to have class. We throw a new keyword on at the beginning. We have what looks like function syntax. It is just a nicer, more concise way of declaring a class. And then we have our extends the same way that Java would, as well as the type that we're inheriting from. So the noise makes sense in an OO context because, well, Scala lives in an OO context or in a hybrid context. So what happens if we throw together one of these things like we do down here? We throw together an expression tree and we want to evaluate it. Well, the evaluator doesn't actually look that dirty. We can extract, for each of those types in an exhaustively checked way, all of the variables inside. So what's really nice is we get a generated unapplied, like you said, and we can bind to L whatever this is over here. Now we could actually put in a literal and we could say, maybe if we're dividing by 0, which maybe we want to check that down here, so we throw an exception if we're dividing by 0, we can actually catch that here in a really nice way. We just say div L comma 0 and it would check that, which I think is really nice, really nice. And then we can recursively evaluate all of that stuff, in which case we will unwrap that, come back through, do our check, hey, we're good. So, what else?
Just a quick question then, on the evaluation for the case cat class matching, is that, because you're doing recursive stuff there, would you still need to worry about tail recursion there? If your term length is humongous?
Yeah.
Okay.
But you're not going to get tail recursion here.
Right, yeah, you won't because it's not written that way.
Right.
But, so that would blow up in a wall.
Potentially, yeah.
Okay.
Now, yeah, it could blow up. It's just a fact of life.
So it's just, I guess, something you need to remember then is anytime you're doing anything recursive, probably best.
Test it on large data sets, see what that.
So a thing
The
you
grammar
were,
here is not recursive. No.
so one of the things he had done earlier was show how to explicitly, it was his list. Well, he had a method, and then there was a bar at the beginning of the method. He did some work, and then as he exited the method, he returned the work. He didn't allow the mutation to escape, and so you still had a referentially transparent function, but the implementation allowed mutation for efficiency in implementation. You could do, basically you would do something potentially similar here, where you would yourself would unfold it into a collapsed while loop and not actually do recursion.
So it's just something to remember, I guess, is
Yes.
you're doing that.
But you're right, you do have to keep that in mind.
Okay.
Yes.
Yeah, most Scala programs aren't written that way, though.
Yeah, right.
Tend not to care because we'll actually flat map or
Yes.
something. So in which case, then we're always exiting back to the same stack frame, so we don't care.
Yeah, you tend to wait from this kind of implementation. I wouldn't say, it's there, but it's more like a one-off case for a tiny domain that you gotta deal with.
Yeah.
Yeah. But then you do have to keep it in mind, you're right.
So there's some other interesting code here that we sort of looked at before. So like val declares a function. So def, as we looked at before, declares a function. But this is, of course, a function literal. What it does is it multiplies whatever expression you have by 2. And so if we actually evaluate times 2 of our expression up here, we would get, well, I think this evaluates to 11, so we would get 22. And this is a really nice, concise way of just writing that function literally. This is an OO feature that I find really, really handy. And we're going to see this a little bit more in a few minutes. But one of the problems that Java has is that we live in an OO land, but we cannot add arbitrary methods to our objects. So if we go back to like the way that Smalltalk used to work in languages like that, we could, or even the way that Python, Ruby, and those languages work, we can't really add new methods to our objects. And it gets really, really limiting in an OO context where every function that you're calling is really a method. And so what Scala does is it provides implicit conversions as well as extension methods. And so this implicit class syntax says, it's very specific in its construction. This has to be a class that can be instantiated with one member over here. Now, it can be generic if you want, but it's at most one parameter right here. So what will happen is you'll instantiate this exp extension class. And now all of these methods, here we've only got one, but we could actually have more, can now be called as regular methods on anything of type exp, which is really nice. So for a long time, this was called the pimp my library pattern. Apparently that fell out of favor because who knows why.
SJWs.
Yeah, probably. So now we actually just go through and call them extension methods. So if I want to have e squared as a method, I can just literally now write e squared, and it looks the way that it should. I can drop the dots if I want, or I can have e dot squared to really call it as a method. And the compiler does all of the magic so that I don't have to go instantiate my adapter class and then call it and then get it and then unwrap it again. I don't have to do any of that. The compiler handles it for me because, well, it's a computer and it should do the work.
Yeah,
So,
it's automated delegation. It's fantastic.
yep.
Is there, can you not run into trouble with having more than that stuff overlap?
There's very careful scoping rules. So yes, if you,
Can
and
you
that
run
did
into
happen
trouble?
early on where people went crazy with it and it started creating all sorts of issues, especially since the IDEs didn't allow you to see the implication. And so your code was running off and executing things you didn't even know it was executing. The IDEs have matured, so they will show you where it has found an implicit pathway. And so you can follow it at that point if you want to tell you which pathway it found. And then the second part is people have gotten much more mature about how to, and basically there's patterns and anti-patterns around how you use implicit now.
And then if the call is ambiguous, like you have two extension methods called squared, it'll just not do it.
Yeah,
Yeah, that's a compiler error. That will result in a compiler error.
In C sharp, you can't, like, it's not like an automated adapter, you can't just override existing methods.
Well, this doesn't allow you to override existing methods.
Yeah, this is an augmentation.
Yeah. I mean, if you name it the same as an existing method, that will error out.
Oh, okay, so it's not.
Because, well, now you get ambiguity, right? The compiler can't tell whether you're trying to refer to the one that exists or the one that you're creating over here in this augmentation.
Actually,
Oh, okay.
if it already exists on the class, and then you make an extension method by the same name, it'll call the one on the class. It won't even look at the implicit scope. So that's one.
Oh, it won't error out?
You don't get a
I
compilation
figured it would
error?
error out.
No, you don't.
Oh, wow, okay.
If it's,
Oh,
so
thank
first, so whenever you call a method in Scala, the compiler first looks and sees, is this method a member of this class? If it is,
Yeah, I guess
If
it
not,
wouldn't want
it
to.
says, does something in the implicit scope provide this?
Oh, so it never checks the implicit scope, so it'll never know there's a collision. That's what you're
Yeah,
basically
yeah.
trying to say. Okay, got it.
Oh, so if it needs to find an overload, then it, yeah, that would make sense. Then it would find it. So,
That's one thing that was
so this is the one thing that had to be discovered because it was never really there by intent, I don't think. Scala actually has type classes. And they are a flavor of type class that is done by convention, but is actually more powerful than Haskell type classes. So, for better or worse. And I've run into bugs where it's been worse. So, the way that Scala approaches this idea is through the idea of implicit. So, imagine that we write a function f, and our precious little fingers have been crushed in a hydraulic press, and we don't feel like typing all that much. So, we want to type and evaluate f in as few keystrokes as possible. So if we always know that f is just always going to take as, its last arguments, some particular element from scope, what we can do is we can make that element, say y here, implicit, and we can make that argument to the function implicit. And what that will do is instruct the compiler to say, every time I call f, now I only have to supply the x parameter, because I have f of x and y over here, basically, without actually having to type that second parameter. As long as, and so this is the contract with the compiler, as long as there is an implicit of appropriate type in scope. And so now there are interesting scoping rules about what implicits apply where, but as long as you fulfill that contract with the compiler, you don't have to do that extra typing, and your hands that have been crushed in a hydraulic press, can heal more quickly. So what's nice is that implicits chain, and recursion can do interesting things to a language. In that, up here, when I define y is just going to be an implicit int in scope. It doesn't itself depend on any other implicits that are in scope. But I can go through down here and define another int that requires an implicit string to be in scope. So now we have our recursion rule. We have our base rule and we have a way of recursion. Now, God, we can do really interesting things. So we really only need those two things to become sort of arbitrarily powerful. In fact, you can actually, whoops, translate in a roughly mechanical fashion. You can translate Prolog code into Scala implicits with as much horror and glee as you can imagine that there is. And it's because it's recursive. It can depend, a single implicit can depend on other implicits being in scope. What's fun, or what's even more fun, is that implicits can generate. They can be generators. So they don't have to necessarily be a constant or a literal or a val, something that already exists. For example, this guy right here promises to generate you something of type int when you request it. It does not say that it's going to be a literal or constant int. It just says I'm going to give you something that happens to conform to that type. And so you can imagine this could be generic. This could be, I want a sequence of something. Well, it doesn't exist now, but I can ask the compiler, hey, go find me a path through all of the different implicits that I have, and this is actually how it works. Go find me a path through all of these different nodes. Prove to me that it works. So what I'm doing when I'm doing this stuff is I'm actually writing a proof for the compiler saying, if these things chain together in the right way, there is a proof that this final element actually exists, and the code that I write is how to generate it. So the type signatures tell you how to destructure, and then the code tells you how to sort of bottom-up construct the evidence of your proof. So we can use this to do all kinds of fun. So say we wanted, I don't know, a show type or type class. We wanted arbitrary types to be able to call show on them and convert arbitrary types to a string. Now the way that we would do this in OO land is to add a method to object, right? Because we always know that we should be adding methods to object in Java.
Always. As many as possible.
Yeah, so that turns out to be a really, really bad idea, as the community has now discovered. But we still want to be able to print our objects in human readable ways, in sane ways. And type classes are a great way of doing that. So what I can do is I can define an implicit show of int, which provides me evidence, a construction of how I print an integer. And I can provide a show of string, which, well, how do I print a string? And I could do that for any arbitrary type down here. In fact, I could even recurse and say, I want evidence that I can print a tuple. Well, I can only print a tuple if I know how to print the individual elements of that tuple. So now I've got some interesting recursion that could go on. I could have a tuple that's arbitrarily deep, because tuples can nest. And now the compiler has to go find me a proof, but a proof actually exists. And it will be just recursing on this show tuple. It's like, I destructured my tuple and I've got another tuple. Well, is there evidence that I can print, that I can show this tuple? Yeah. So until I get to my base cases of an int, I have an int. Is there evidence that I can show an int? I don't even need to find these other things. But if I show up with a type like double that doesn't exist, hey, do I have a show of double? Well, no, it doesn't exist. There's no evidence that I can go do that. There's no proof that exists.
So these are just a compilation error that says evidence missing, correct?
Effectively, yeah.
Does the implicit keyword apply to both tuple parameters, or is there a reason why?
Yes, it does apply to both.
Okay.
And once you use it, it applies to all parameters remaining, correct?
Yep.
Yep.
In that group, in that parameter group.
Yes.
Yeah.
This is just
Very
effectively
good.
a type class. These are just effectively type classes from Haskell.
Show is now effectively a type class, yeah.
But is it only in that scope for this module or whatever this is?
Well, let's talk about that in just a second.
It's a whole different conversation that's very.
Yeah. So what if I wrote a method show right here that took an arbitrary type? Well, how would I use my type class? Well, I would just ask the compiler for evidence that I have a show of t. And if this exists, it will be found and this code will compile. And if it doesn't exist, it will not be found and this code will not compile. So you know that when your code compiles, you actually have that object, you can use it, you can call ep.show on it, and actually turn your whatever it is into a string, which is really, really handy.
So that method only exists as a signal to the compiler? Or is it not just deferring to your concrete method?
So when you so if you were to look at decompiled Scala code, what you're actually going to see down here is a reference to probably a synthetically generated class, depending on which of these instances you're actually calling. With show of 1, you would see an actual static reference to this guy right here, to show of int. And so your method call would just have show of int in its name. It would just be show of int of 1, basically.
Okay.
And it would just be statically that in Java. Now, what's going to happen as your type classes nest, it's going to synthesize something, or actually just, it'll probably just synthesize it. These individual instances, because it knows how to generate them, right? And it will say, oh, I'm doing a tuple. Well, let me do a show tuple of 1, and then let me throw into that second spot a show of int, and into that other spot a show of string. So if where'd my...
Have you verified that, or are you speculating?
No, because when we actually did the decompiler, that's what we saw. That's how it actually works.
It just seems to me that it would just pass in as some derivative of show, right? Declare some interface, show.
No, it actually makes reference to these functions up here.
Okay.
Yeah, it's really kind of interesting. Because as it turns out, when you get down to the Java layer, these are just regular functions. You just need to supply parameters too.
The rest of the stuff is just for the compiler.
Yeah.
Yeah, the last show function is just for the compiler? This would
No,
overly
that's
generic
an
one.
actual function, right?
Yeah, this would just be another function too. It's just that this parameter is synthesized from the other potentially nested function calls from your functions up here.
Do you need the last definition?
You don't have to use it. I mean, if you want to.
Yeah, I mean, if you don't want to be able to show tuples, you don't
Okay.
need it.
The bottom one's a generic show.
Oh, I see.
It's like for
Yeah.
all showable types.
Right. Yeah, the names are different.
And potentially you would have this inside a package. He's probably going to describe this in a minute. You would have this in a package
Right.
that you're going to import, and then you are going to write your own show my custom class implementation. That makes sense? And
right.
then you're going to make that available, and then that package will utilize that to show your objects, your classes.
The compiler specializes at the end when it knows that it has this way of reaching
Yes.
whatever.
Right.
Yeah, so so this is where implicits get real fun, because implicits have to be findable from a scope that you're in. So there's actually a fairly complicated algorithm where it will go and enumerate all of the implicits that are in some scope, and then it will actually rank order them. And if any two implicits that satisfy the same type parameters are in the same scope, well, that's ambiguous and that's an error because they have the same rank. So if, for example, I had two different show of ints, oops, I can't actually see my cursor, two different show int up here, that would be an error if I ever actually tried to grab an individual show int because it wouldn't know which one to grab. Now, I've made a proposal that Scala should have a way of fixing this or enumerating all implicits in scope, which I think would be really, really cool. But the way it works right now is you can have multiple implicits that satisfy the same types as long as they are basically different ranks. Now you always have that uniqueness constraint, but what's interesting is that if you put one of these implicits, so these things are all, for lack of a better word, implicitly inside an object. So all of this code lives as code inside of a Scala object. Well, Scala objects can inherit from traits. Implicits can live in traits. And traits are one of the places, or inherited traits, are one of the places that you will look for implicits during implicit resolution. Well, it turns out that actually lowers your rank. And so what you're able to do, and this is a really common pattern, is a library that makes use of type classes, like plays JSON, will throw all of its implicits into a trait. It will have an object that pulls that trait down if you want to use it easily. And then if you want to provide overrides, well, you can in the current scope. And it will be the most specific, closest, highest ranked implicit, and therefore the one that's unambiguously best. And the one that you
So you're basically saying that, so show, in your example here, show int is potentially in that trait, but when you go to implement it yourself, in other words, when you inherit from that trait to create your instance, you're overriding the method, causing that one to disappear and yours to be the override, correct?
Yep.
Okay, got it, thank you.
I mean, you can use it if you reference it explicitly, but by default, implicit resolution will find that one that's highest ranked.
Got it. And what you did is you obscured the older one with an override. It's a method override. Is that accurate?
No, it's not a method override at all.
Okay, so how
It has nothing to do with method overrides.
Just who's the closest to me that I can
Yeah.
get this implementation? Yeah.
Okay, interesting.
So one of the ways that this helps is with the library shapeless, which actually uses this priorities mechanism to declare implicits that will match wider scopes. So for example, and let's actually bring up,
It keeps seeing bright and then filtered. Yeah, so is the brightness being dimmed down on the monitor? Is that coming from the projector or is that from your laptop? It's very bright when you first flip, it's very bright and then it diminishes.
I think it's an overlay because this cursor is quite bright. Everything else-
So what? Oh, there you go.
Yeah.
Okay.
sorry about that.
It's okay?
Sorry.
Yeah, that's actually probably a little on the bright side now. We're all used to the other one.
There you go. Okay, so we actually have a way of doing
Enlarge.
oh
You
yeah,
gotta
sorry.
make that much bigger.
Yeah, there we go, perfect.
Yeah.
Okay.
Better.
There we go. Scala, this had to be discovered too, but we actually have a way of doing natural transformations within the language, and a way of describing polymorphic functions, functions that can be over any type, specific to that type, if that makes sense. So like size here is equivalent to a function that if it sees an int will return 1, if it's evaluated on an int will return 1, if it's evaluated on a string will return the length of that string, and if it's evaluated on a tuple will return effectively recursively the size of the first element plus the size of the second element. We can see how this is similar to the implicit stuff that we were looking at before. Well, so we can evaluate it and you can see how it's doing the right thing. What if I had a case that would accept an arbitrary type? Because I didn't want it to error out. If it was a type that I'd never seen before, just return 0. Well, what happens when I try and write that code, but I have these problems with ambiguous implicits? So like, if I were to put that case of anything in this same scope, and then I tried to evaluate it, well, which implicit should I use? Should I use the case of anything or the case of int? Well, that's an error. So we can get around that by having default implicits live in a lower priority scope. So the way that we do that is we have size extend from a trait that includes just that implicit. And so now what will happen during evaluation, if I send in size of fuzzlebub, which is of type fuzzlebub, well, int, it's not a string and it's not a tuple, it would go to that other trait.
But it
Oh,
has
that's
lower
an
priority.
int.
Okay.
I know that that can be evaluated to 0,
Okay.
and therefore I'm good.
Awesome.
And so that's actually a trick that's used almost all over the place when we're doing shapeless-like stuff to handle that base case when we're basically destructuring each
Poly 1
list.
contains the any case, is that what you're saying?
No, poly 1 is actually, poly 1 actually says it's a generic of 1 type up there. So if it was poly 2, there'd be 2 types here.
Oh, I see.
Yeah.
So is poly 1
It's the
inherent from
arity
poly
of
0?
the types, effectively.
Oh, I see. Okay, so you could actually have extends poly 1 with poly 2.
No. So poly 1 means that this type list here has one element.
Got it.
So you could have int and string, and that arity is the arity up here. So the
Gotcha.
same way that function has that arity.
Yeah, yes. Oh, I
the
see.
same thing here.
I get it now. Okay.
Okay, so I think that's the last of the magic that I was going to show. Except for this, which is the Scala Z stuff. So say we actually did want to write a pure functional program that would just print some of the letters of the alphabet. How would I do that? Well, print letters here is effectively a program that when it's evaluated by Scala Z, will print the uppercase versions of A, B, and C. There's no magic there. It's the same thing that Haskell is doing. We're just wrapping our effects up in the I/O monad. But we actually have, as Scala programmers, access to all of that machinery. And if we want to use it and leverage it, we can. So, and that's effectively what print Sterling is doing down here. Is that it's creating that I/O so that when I map through, that final string is an I/O string. It goes back up. Yeah.
I think if you do traverse put Sterling, you'll end up with a single I/O containing a list of things to be printed.
Yeah. This was sample code that I wrote a long time ago.
I wasn't sure. It's something that's super useful that not a lot of people know about.
Traverse and Haskell even, most people don't use it.
Yeah.
And the reason you would use it is?
If you ever do .map and then .sequence to put the types, .traverse is equivalent to that.
Okay.
It skips the.
Skips the intermediate building up of the results and then flattening it.
Okay.
Yeah, because what this is actually going to return is a list of I/O. So you're going to be sort of lazily creating that. So I hope I've convinced you that you can definitely go far in terms of like the functional programming that you have access to in Haskell, or in Scala. You can write almost as much of Haskell as you really want in Scala. But we have to think back to just how broken it's actually going to be when we start interfacing with other people's code. And that's really the trade-off that we all make, right? So the code that we write is beautiful and perfect, and then as soon as we push it into Git, and other folks start looking at it, it's terrible. Well, that's just life. So,
Yeah, I think that transcends every language,
yeah.
including English.
So, does anybody have any questions, comments? I hope I've convinced you of stuff. I'm not really sure.
Yeah, how much of this do you get away with at work?
Like how much of the functional programming do we actually do?
Well, I know that probably vary from workplace to workplace. But,
It really is, yeah. And it depends a lot on the competency of the programmer. Like a programmer that really has just freshly come from Java is going to write Scala that looks like Java. A Scala programmer that has just freshly come from Haskell is going to write Scala that looks a lot like Haskell. So, and when those two try and talk, oh man, there's all kinds of fun that happens.
Hey, that happens just within Java.
Yeah.
Java newbie versus
So-
Java architect.
Yeah, so it gets interesting.
Do you guys use Scala Z at work?
In a very limited capacity, and it's mostly because we interface a lot with Java. About half of our code in our code base is Java, and there's just not a reasonable way of getting the two to mix together. So, I mean, it's actually hard enough to get option to live well off in Java land. So, I've actually had issues because of type erasure where I couldn't get double to work right, because Scala's double is actually it's actually a different double than Java's double. And so I was running into fun issues that way. And so the problems that you run into with interop are not always fun.
So are you saying Scala Z reduces some of the complexity of doing Java interop? That's what.
No, I'm not saying that at all.
Oh,
I'm
it
saying
increases it.
Increases it a
Oh, okay,
lot.
got it.
So, yeah, we don't really use Scala Z hardly anywhere. We use type classes in a couple of places, but type classes effectively make calling those methods that use type classes impossible to from Java. And so I was actually talking to guys today about code that I would love to use type classes on, or just some other method. So we effectively have this matrix of different classes that we have to instantiate because of different capabilities. So we have this N by M problem. I would love to have a factory method that could just give me back, because it's all the same interface, just with different capabilities underneath, one thing. And in Scala, I can express that very nicely. But I can't express that or call it from Java.
So there's two directions here. What I hear, so the direction I primarily use is I'm in Scala and we use Java libraries. So I have very few Java interop issues. It seems to work very smoothly.
If you live just entirely in Scala, your life is going to be nice.
So what you're describing is when you have to call, you have Java calling into Scala. Is that what you just described?
Right.
I've tried to avoid that just because
that's very
train
hard.
wrecks everywhere on that. Okay.
Which is honestly, an hour and a half ago why I was making fun of Frege, which is the Haskell variant, because Frege is a language, because it's Haskell, Java can call into that with no problem because it's always pure.
I get that.
But it's also the most useless thing that you can do. So,
I mean, if you are looking to introduce Scala Z in your environment, and I know Scala teams have a lot of debate on whether to bring in Scala Z or not. One of the easiest way of bringing it in is data validation. If you do a lot of data validation, let's say you have workflows where you need 50 parameters to compute something, try to do data validation in Scala Z and it becomes very, very easy. And that's like your gateway drug into Scala
I
Z
get
world.
it.
And once you do your data validations in Scala Z, next thing you will see is that, for example, if you use either a lot, so sometimes if you are calling many functions, you can have either, because so then you need to flatten those structures out, and even there Scala Z helps a lot.
Okay, very nice.
There's a concept, any language, there's a concept of a functor, especially a fricative. You don't even know that, but functor and fricative goes really, really far. Validation works.
Got it.
What's that?
no, I was just saying the videotape you guys.
Oh,
So
Mine?
the mic pickup. Any other questions, comments, concerns, worries?
excellent overview.
Thank you.
Yeah, it was.
Thank you.